Imagine the most violent event the universe is capable of producing. Not a volcano, not an asteroid, not even a supernova. Two dead stars, each one heavier than our sun, each one compressed down to the size of a city, hurtling toward each other at nearly half the speed of light. The question is this: what would happen if that collision occurred near Earth? And the answer, well, the answer is stranger and more terrifying than almost anything else in physics. Before we get to the collision, you need to understand what a neutron star actually is, because these are not normal objects. When a massive star, something 8 to 20 times heavier than our sun, reaches the end of its life, it explodes in a supernova. The outer layers get blasted into space. But the core collapses. It collapses so fast and so completely that the pressure becomes almost incomprehensible. Protons and electrons get crushed together into neutrons. The whole core becomes a single, enormous atomic nucleus. What you are left with is a neutron star. A neutron star typically has about 1.5 times the mass of our entire sun, but it is only roughly 20 kilometers across. To put that in perspective, take a sugar cube, fill it with neutron star material. That cube would weigh roughly 1 billion tons. That is what we are working with. And we are about to collide two of them. Neutron stars can form in pairs. When two massive stars exist in a binary system, orbiting each other, they can both go supernova, one after the other. If the system survives both explosions, you end up with two neutron stars still locked in orbit. But here is the thing: they do not stay in a stable orbit forever. As they orbit, they radiate energy. The energy leaves the system in the form of gravitational waves, ripples in the fabric of space-time itself. This was actually predicted by Einstein and confirmed when we detected exactly this kind of system in 1974. As the energy bleeds away, the orbit shrinks, slowly at first, then faster. The two stars spiral inward over millions or billions of years, until finally they are close enough that nothing can stop what comes next. The actual merger takes milliseconds. Two objects, each denser than anything you can imagine, slamming into each other at somewhere between 1/3 and half the speed of light. What happens next depends on their combined mass. They might form an even more massive neutron star, unstable, spinning wildly, or they might collapse directly into a black hole. Either way, the explosion that follows is called a kilonova. A kilonova is not a normal explosion, it is a nuclear forge. The conditions are so extreme that atomic nuclei are built on the spot. Heavy elements synthesized in real time. Gold, platinum, uranium, almost every atom of gold on Earth, the gold in your jewelry, in your phone, in the vaults of every bank on the planet, was forged in a collision exactly like this one, billions of years ago. That is not a metaphor. That is literally where it came from. But we have not answered the real question yet. What if this happened near us? A neutron-star merger does not just release light. It releases a gamma-ray burst, the most energetic explosion in the known universe. A focused beam of pure energy, moving at the speed of light, carrying more energy than our sun will output in its entire 10 billion-year lifetime, released in seconds. If a gamma-ray burst were aimed directly at Earth from within a few thousand light-years, it could strip away the ozone layer on the side facing the burst in minutes. Without the ozone layer, UV radiation from our own sun becomes lethal. Photosynthesis collapses. The food chain collapses. This is actually one of the leading hypotheses for the Ordovician mass extinction, roughly 445 million years ago. A gamma-ray burst from somewhere in the galaxy. And that is from thousands of light-years away. Now imagine one much closer. The nearest confirmed neutron star to Earth is roughly 400 light-years away. The nearest known binary neutron star system is much farther, so in reality we are not in immediate danger. But let us run the scenario anyway. If a kilonova occurred within, say, 100 light-years of Earth, the gamma-ray burst, if aimed at us, would be catastrophic. Ozone destruction, radiation exposure. The sky would briefly be as bright as a second sun, even from that distance. But here is the thing about gamma-ray bursts. They are beamed. Narrow jets, fired outward from the poles of the collision. If the burst is not pointed at us, we might survive the light show entirely. We would still feel the gravitational waves, ripples moving through everything, including the atoms in your body. Utterly harmless, but real. We might see the kilonova as a bright new star in the sky, glowing blue, then gold, visible for days. Astronomers would lose their minds. And the heavy elements ejected, the gold, the platinum, would slowly disperse through space. Some of it, millions of years from now, might seed future solar systems. The violence of the collision becomes the raw material for new planets. Maybe even new life. This is not just a thought experiment. On August 17, 2017, gravitational wave detectors on Earth picked up a signal. LIGO in the United States and Virgo in Europe detected the unmistakable chirp of two neutron stars spiraling into each other and merging, 130 million light-years away. Within 2 seconds, gamma-ray telescopes detected a burst from the same direction. Within hours, optical telescopes found the kilonova, a glowing, blue shifting fireball turning red as the heavy elements formed and expanded outward. For the first time in history, we watched gold being made in real time. The light from that event, the gravitational waves, the gamma burst, all of it arrived at Earth at essentially the same moment. Einstein's prediction that gravity and light travel at the same speed confirmed across 130 million light-years. The universe handed us proof of one of the most fundamental ideas in physics, wrapped inside the most violent event we have ever witnessed. So, what would happen if two neutron stars collided near Earth? If the gamma-ray burst was aimed at us and the distance was close enough, the atmosphere would be damaged. Life would be in serious trouble. The sky would burn with more energy than we have language to describe. If the burst was pointed elsewhere, we would watch the most spectacular light show in human history. A kilonova, visible in daylight, raining gold across the cosmos. And we would survive to study it. Either way, the collision would remind us of something we already know but rarely feel. Every heavy atom in your body, the iron in your blood, the calcium in your bones, the trace gold in your cells, came from violence on a scale that erases galaxies. You are not separate from the universe. You are made of its most extreme moments. If that idea makes you want to explore more, subscribe. Every week we take a question like this one and follow it all the way to the edge of what we know. Next time, what actually happens inside a black hole, past the event horizon, where the laws of physics as we know them may simply stop working? That one is worth sticking around for.